Come on guys, let's learn Docker today. So what is Docker? Docker is a platform that enables containerization. So let's learn about containerization first. So in old days, developer deploys their application on physical servers. Then after some years, they started deploying their application on virtual machines. So we know that these virtual machines are installed on top of this physical server. So deploying application on physical server or these VMs works fine, but the pain point is, so once the developer develops this application, he deploy that application on dev environment and he tests everything here, and if everything works, then he transfer that code to testers and tester test the same code in their environment. But the same code might not work in this particular environment because of some dependencies or OS packages or anything. Now developer says it is working on my environment and tester says it is not working on my environment. Now whose fault it is, developers or testers? So fault is with environment setup, right? So at that time there was a requirement for a technology irrespective of environment the app should work. So the tech is nothing but the containerization. So in container, instead of code, we package code, dependency, config file, everything. Docker is a platform that enables containerization. We generally run these containers on top of a virtual machine. And container is not a replacement for virtual machines. We generally use VM and container together, and we run multiple container on top of virtual machine. And all of these containers use OS or kernel of this host virtual machines only. So containers won't have its own OS. So let's see some key features of containers. So first one is portability. So containers consist of code, dependencies, config file, everything, right? So that means they can be easily moved across different environments without worrying about any compatibility issues. That is nothing but portability. Second one is container is lightweight. So unlike VMs, which require a full operating system for each instances, so containers share the host operating system's kernel only. That means faster start time and lower overhead. That's why containers are lightweight. So in one VM, we can host multiple containers, but all of those containers runs in isolation from each other. That means in one VM, we can host multiple applications, and those application containers doesn't interfere with each other while running. Since containers include everything the application needs to run, they ensure that the application behaves the same way, regardless of where it is deployed. That is nothing but consistency. So containers are designed to be easily scalable, so you can run multiple containers when the load is increased, and you can orchestrate these containers using applications like Kubernetes. So we'll learn Kubernetes also in this course. Stay tuned for that. So now let's install Docker and let's create our first container. So let's install Docker now. So to install Docker, we need a virtual machine. So let's create instance or virtual machines now. So to create instance, we can use any one of the cloud platform like AWS, Azure, or GCP. So I'm using GCP, and here I'm going to compute engine and click on VM instances to create a VM. So in GCP you will get 3 months or 90 days free trial, so you can utilize that for creating any instances or to learn in GCP. Also you can use those 90 days free trial. So I'm using that now. So click on create instance here to create one of virtual machine. So you can give a name for this particular virtual machine. I will give Docker demo. Then you can choose region and zone. So I will keep it as default, and I will keep everything as default. And I will change the boot disk actually. So in boot disk I can change it to Ubuntu. So I am comfortable with Ubuntu, so I'm choosing Ubuntu. And boot disk version will be 20.04 is fine. So that is LTS version, and size I will change it to 20 GB. Then click on select. Then I will allow HTTP and HTTPS traffic because I'm going to create a container application. So to access that particular application, I need HTTP and HTTPS traffic. Then let's click on create. So my instance is created now, and to access this instance, I have to add my SSH key into this particular instance. So let's create SSH key in my local. So for that I have the command called as SSH keygen. So we can run that. So let's paste that command and it will create a SSH key pair now. Then give a path, and I'm going to override that previous key. Then it's created key now. This is the path for a public key. So I'm going to copy this key and paste that in my instance. So copy that and cat that path and copy this key into my instance. So click on edit in the instance and search for SSH and add item, and paste your key here and click on save. So now SSH key is added to my instance, so I'm going to access this from my local. For that I have the command SSH, then my username, that is Sandesh2026, at the IP I can get it from this particular instance. External IP I have to add. So if I go here and I can copy here external IP and paste it. So now I have logged into my instance. Now let's install Docker. So to install Docker, search for Docker on Ubuntu in any browser and click on first document, that is install Docker engine on Ubuntu. Then run these commands. So install commands. So copy those commands and run those commands. So first it will update my OS packages and other things. Then it will install the Docker. So it will take a couple of seconds or maybe 30 seconds or 1 minute to install all these packages. Let's wait for that. So once all the packages installed, then run next command, that is sudo apt install Docker engine and other things. So copy the command and paste. So Docker is installed now. To verify that I have to run one sample image, that is hello world image. Let's run that. So here you can see it gives the message like hello from Docker. So that means Docker is installed, but it is installed in root user. So let's switch into root user first. So sudo su. So now let's create an application using Docker. So to create any application, what we need source code plus dependencies, right? So first I need code. So I'm not going to write code now, but I'm going to copy the code from my GitHub repository. So I already have the source code here. So I'm going to copy this into my VM. For that I can run git clone and paste the URL link. So it will copy my source code to my local. So I will add this GitHub repository link in my description also. So you can also clone this repository and you can use that. So it created a folder called as node.js docker, that is my repository name. So we'll go inside that directory and here I have the code. So this is the node.js code, and first we see how we can deploy this without using the container. So to deploy node.js application, we need platform first. That platform is nothing but node is platform. Then we need source code. Then we have to install the dependencies. Dependencies we generally add it in package.json file. If you see package.json file here, it will list all the dependencies here. Here you can see express and body parsers are the dependencies. So you have to install these dependencies. For that we have the command called as npm install. Then we are going to run my application using node server.js. I go to node.js-docker. Here I have the code server.js. This is the main JS file. So we are going to run this application code. Now let's see how we can deploy this using the container. So we can't create Docker container directly. We have to create it from a template. That template is nothing but a Docker image. So to create a Docker image, we have to create a file. That file is Docker file. So this Docker file consists lot of instructions to carry out these particular actions. So let's create a Docker file now. So we create Docker file in the same folder where my source code is exist. So here only I'm going to create a Docker file, vi Docker file. And this Docker file I have to add all the instructions. So my first instruction will be adding the platform, that is node platform. So similar to GitHub, I have the Docker hub. Here I can search for any base images. So node is my base image now. So search for node. There will be official node image will be available. So I'm going to use this particular image now. For that, in Docker file I can add node. The instruction will be from node. So I am going to add this node as the base image for this particular Docker image. So my next instruction will be copy the source code. So for that I have the command called as copy the source code. The source code exists same directory as the Docker file, so I can just give the dot, and the destination directory can be anything. I am going to add it as an app directory, so it will copy the source code into this particular app directory in my Docker image. So next instruction will be installing the dependencies. For that I have the command npm install. So I have to run this command. For that in Docker file I can run npm install, and to run this command we have the Docker file instruction, that is run. So this npm install will install all the dependencies that is listed in this package.json. So this package.json should be there in the same directory. So this package.json will be there in this /app directory because I have copied source code into /app directory. So I have to change the working directory. For that I have the command called as workdir into /app directory. Then I have to run the application using node server.js. So this run command will not work because this run command will run while creating the image. So I have to install the dependencies while creating the image, but I have to run this application while creating the container. So to run while creating the container, I have the command called as cmd instead of run. And cmd has its own syntax. So I have to add the command in a square bracket and with the double quotes, and will be separated with a comma. So run will execute while creating the image, cmd will execute while creating the container. So just remember the difference between run and cmd. Then one more thing, this is a web application and web application generally has the port. So if I check my server.js file, it will have the port defined in that particular file. If I check here and you can see here app listen 80 port. So it is listening on 80 port. So I have to add that also in my docker file. So for that, add an instruction called as expose 80 port. Then just save the file. So now my docker file is ready. Now I have to create a docker image from that. So to create or build a docker image, I have the command called as docker build and the path for docker file, that is dot only because docker file exists in same directory. So docker build dot. So while creating image, it will execute all the instructions that I have defined in my docker file. You can see here from that node image, then copying the source code, then working directory change, npm install. So all these instructions will be executed while creating the image. So once image is created, I can run docker images to list the images created. So I can see two images here. One is hello world, that is created while installing the docker. This is the image created now. Now I'm going to create a container based on this particular image. So now let's run docker run and the image, that is this image id. If I run this and if I try to access this from my browser, so in browser you can access this from my external IP and the port is 80. So we got a site can't be reached page. So if I check my docker file, I have added a step called as export 80 port. So this 80 port will be my application or container port. I have to mention one more port called as host port. So this expose 80 port is just a documentation step. So it just gives information like we are using 80 port as the application port. So if you don't add this step also, it will work same way. So as the best practice, you can add expose 80 instruction, but the important thing is while running docker run, I have to add a command called -p flag. I have to give my application port, that is 80, and before that I have to mention the host port. That host port can be anything, but I am going to mention 3000 as my host port. Then paste image ID and click enter. Now in browser, if I open with the same external IP and the port 3000, the app should be open. Now if I add anything in browser, it should reflect in my command line also. If I click on set channel goal, now if I check in my command line, it's added here also, teach docker. So now we have containerized this application. Modify the source code and then let's see how that change will reflect here. So let's modify the source code. So I'm going to modify this server.js file. So vi server.js. So I have modified this line here. Instead of my channel goal, I have added as my course code. Then I'm going to save this file. So here instead of my channel goal, it should change it to my course code. So how that change will reflect here? I just refresh this page, but still it is my channel goal only. So just refreshing the page will not work. Now let's try stop and starting the container. So for stopping the container, I have the command docker stop and the container ID. So first I have to have the container ID. For that I can run docker ps. So docker ps means docker processes. So it will list the all running containers, not stopped containers, only running containers will list. It will list. So I will copy this container ID now. Then I will run docker stop that particular container ID. So container is stopped now, and if I check on my browser page also, I get this site can't be reached page. Now let's start this container and let's see my source code changes are reflecting or not in my application. So for starting the container, I can run docker start and the same container ID. It started the container. Let's see that in browser also. So it started. But here you can see the content is my channel goal only. It's not changed to my course goal. So source code change is not reflecting here, even after stopping and starting the container. So let's create a new container from the image and see whether that reflects my changes or not. So to create a container, I have to run docker run -p
and the host port that is 3000 and container port or application port that is 80, then the image ID. So image ID I can get it from docker images command I can run, then it will list all the images. There I can get the docker image IDs. So I have created a new container now. Now let's refresh this page. So it is still giving my channel goal only, not my course goal. So changes are not reflecting, even when I create a new container from the image. So what's happening here? So when I check my Docker file, I explained cmd will run while creating the container, but all other instruction will run or execute while creating the image. So copy code is one of the instruction here, and that executes while creating the image. So while creating the image, whatever the code is here, it will copy that code only. So if I modify any file here, I have to execute this copy instruction again. So to execute this instruction or Docker file, I have to create a new image from this particular Docker file. So let me create a new image now. So to create image, I have the command docker build and the Docker file path that is doc. So it created a new image. Let me list that image. So this is the new image created 15 seconds ago. Let me copy this image ID and let me create a new container from this particular image. So before creating the container, let me stop the previous container. I have stopped the previous container now, and I am getting site can't be reached page. So now let me create a container from the new image. For that, docker run -p, the host port 3000 and the container port is 80, and the new image ID. Now if I go to browser and refresh this page, now I am getting my course goal here. So my changes are reflecting. So whenever I modify my source code, to reflect that, I have to create a new image from my Docker file. So once the image is created, it is read only and the image is locked. You can't modify or write anything to the images, but you can modify the containers. So now let me explain the layers in Docker image. Now if I check my Docker file here, each instruction will be a layer. So Docker image is nothing but group or stack of these layers. And these layers will help in caching. So for example, here from node is one layer. And if you build another image and that also uses the from node instruction, then Docker can reuse this layer and that will speed up the build process. So that's how caching works here. So similarly, copy code also one layer here. So if the code is not changed, it will not rebuild again, it will use the cache. Similarly, if the package.json file is not changed, there is no need to execute npm install command again. So it will save a lot of build time. So these layers can be reused. And one important note here, order matters here in Docker file. For example, there are some code changes. Then Docker will rebuild this copy layer as well as all the subsequent layers. That means it will execute again work directory, npm install, all these instructions. So if you place instruction that change frequently early in the Docker file, then subsequent layers also will need to be rebuilt frequently. So that means it will slow down your build process. So as a best practice, you have to place instruction that changes frequently at the end of the Docker file. So that's it about Docker layer and caching. Also, you can check the layers of the image using docker image inspect command. Command will be docker image inspect and the image ID. So it will show all the layers used in this particular image. Come on guys, let's see what is detached mode in Docker run. So in previous session, we created container using this command and the container will run in attached mode. Attached mode means this container session is attached to your terminal. So once you execute docker run command, you can't execute any other command in this particular terminal now. And if you add anything in this application UI, that will be shown in terminal also. That means logs of this particular container is attached to this particular terminal. So this mode of running, we call it as attached mode or foreground mode. And if you want to run this particular container in background, we have something called as detached mode in Docker containers. I have stopped the previous container because I am going to run a new container in detached mode on same port. Now how can I run this particular container in detached mode? For that you have to add one more flag in the command. And if you don't know the flag, then you can run docker run help. Then you can say -d or -- detached to run container in background mode. So now let's run this container in detached mode. I have added -d flag, and if I click on enter, so it gives the container ID and the terminal is not attached to this particular container now. So now if I add something in application UI, unlike in attached mode, the logs will be not shown in terminal now. Now if I want to see the logs of this particular container, then I have to run the command docker logs and the container ID. So now it will print the logs. So now if I add something else here, and if I want to see that logs now, I have to run the command again. Now here you can see the logs. Now if I want to see the real-time log like in attached mode, I have to add a new flag called -f or --follow. So now this will give the real-time log. So now if I add something here, that will be updated in terminal automatically because now I have added -f flag. So that is about Docker detached mode and Docker logs. Now I have created a new file here, test file. And if I want to copy this file inside the container, how can I do that? For that we have a command called as docker cp or docker copy. The syntax is docker cp, then the source file is test file, and the destination will be the container ID. And I can give the path inside that container. I will copy that into the /app directory inside this particular container. So once I ran that command, you can see here successfully copied to /app directory inside this particular container. So now how to verify that if the file is copied to /app directory or not? So for that I have to go inside the container. For that I have the command docker exec, and with the exec we have to add some other flags. So to check the flag I can run docker exec and -help. So generally docker exec we execute with -it. So I is for interactive mode and T is for terminal. So T will allocate a terminal for this particular container. So now I am going to execute the command docker exec, then -it, then container ID, then I can give a shell path that is bin/sh or bin/bash. Now I am inside this particular container, and if I run pwd, it will print the working directory, that is /app. Now if I run ls, you can see the test file here. So test file is copied to this particular container inside /app directory. So like this I can copy the file using docker cp and log into the container using docker exec. So to debug anything inside the container, you can run docker exec command. And if you want to exit from this container, you can just run exit. So now if I want to copy the file from container to my host, so now I have deleted my test file in my host. And if I want to copy that file from container to this host, so now command for copying the file from container to host will be docker cp, then the container ID, then the file path that is /app/test file, then the destination will be the current directory. That's why I have added dot. So once I run that, the file is successfully copied to the current directory and the file is here, that is test file. So docker cp is not mostly used command. So generally it is used for, so in some case the logs are generated inside the container. And if you want to copy those logs from container to host, then you can use docker cp command. Today I'm going to create some simple application like adding two numbers or printing maximum number. For these use cases also you can use Docker. Today I'm going to create a simple Python application using Docker. So application code is in GitHub. First I will clone that code. I will copy this link, then git clone and the URL, and I have to start downloading my code. So my source code is ready. Now I'm going to create a Docker file, va docker file. So in Docker file, I have to add instructions now. So first instruction will be the platform or base image. So my application is Python, and if I search for Python in my Docker hub, I will get the Python base image. I'm going to use this image now. So to use the base image, I have the instruction from and the image name. And image name is Python now, and this is case sensitive. So if I give PS capital, then it will not work. So next I have to copy my source code to container. For that we have the instruction called as copy, then the source directory, that is dot, because Docker file is in the same directory as source code. The destination directory can be anything. I will mention as a /app directory. So our source code will be copied to this /app directory. Next I have to run the Python application. So I have to run this sample code.py. Generally we run Python code as Python, then the Python code file name. So this command should run while creating the container. So I have to use cmd. So cmd has its own syntax. I am going to change that now. So we have to give cmd in a square bracket. We have missed one step, that this file is in /app directory. We have to change the directory to that /app now. For that I can use workdir. So I have added workdir /app. So my Docker file is ready now. Let's save this file. Next I have to create an image from this particular Docker file. For that I have the command docker build, then the Docker file location, that is dot. So Docker image is created now. So this is the Docker image that is created now, that is 24 seconds ago. Now I'm going to create a container from this particular image. For creating container, docker run. If this is a web application, then I have to mention port and other things, but this is not a web application. So I'm just going to give the image ID only. If I run this now, it gave an error like this. It is because if I check my code, here minimum number and maximum number I have to give it, that is as an input. But for now I can't give the inputs while creating the container. So to solve this we have the interactive mode, so that I can give the input while creating the container. So I'm going to run the same command with the additional flags, that is IT. Here I is for interactive and T is for terminal. So if I run this now it's allowing me to add the input. So I will enter the minimum number and maximum numbers. So I gave 1 as minimum number and 9 as maximum number and printed 4. So here code is, it will print the random number between the minimum number and maximum number. It uses rand in Python function here. So when we run docker run, by default it will run in foreground mode. That is, terminal should be attached to this particular session. But if I run docker ps here, there is no running container here. That is because in this application, when the random integer is printed, the container will go to the stop state. So if I run docker ps-a, it will list all the container including stop containers. So this is the Python application that is in stop state now. Here you can see status is exited. So now let me try to start this container back.
So for starting the container, I have the command docker start and then the container ID. But remember, while starting the container, it always start in the detached mode. If I want to start this in attached mode, I have to give an additional flag -a. Then I have to add -i flag because I have to start this in interactive mode also. There is no need to mention T here because terminal is already attached while creating the container. While starting T is not required. So now if I run this, so like before, I can give the minimum number and maximum number and it will print the random number. So that's it for interactive mode. Come on guys, let's run Docker registries today. For now, only I am using the image what I have created. But in real world, multiple developers will use the same image. So we need a centralized place to store your images. That centralized place is nothing but Docker registries. Like we store our code in GitHub, we can store our images in Docker Hub. Docker Hub is one of the registry. It's a public registry actually. We can use other private registry also like ACR, ECR. For this session, I am using Docker Hub as a registry. So I have logged into Docker Hub now. Let me create a repository first. So in repositories, click on create repository. Then you can give a name here. I will name it as node app because I created a node app. So then you can create a visibility, public or private repository. Public means it is visible to everyone and private means it is visible to only you. I will create public repository now, then click on create. My repo is created now. If I want to push my Docker image, I can run this command like docker push, then the repository and tag name. For that, first I have to tag my images. If I run Docker images, I can see only hello world image as a tag. All other images I have created doesn't have any tags. So first I have to add tag to my image. I'm going to add tag for this particular image now. Command for tagging the image is docker tag, then the image ID, then the actual tag. That is this Sandesh 2027/node app, that is the repository name, then colon the tag name. I'll copy this now. So here this is the repository name, tag name I can modify. For tag name you generally give the version. So this is the version 1.2 of this particular application. Then for the next release I can tag it as version 1.1. So let's run this command now. If I run again Docker images, now you can see this particular image has both repository as well as tag. Now I have created a tag. Now I can push my image to Docker registry or Docker Hub. So command will be docker push, then the repository name, then the tag. Here tag is version 1.0. If I run this now, I got an error, access denied error, because not anyone can push their image to my repository, right? This is the public repository, means anyone can pull the image from this particular repository, but not anyone can push their image. So to push the image to the repository, they have to authenticate first. For authentication, first you have to run docker login command. So command will be docker login -u, then the username of your Docker Hub. That is Sandesh 2027 now. Now it will ask the password. For password, you can use the token of Docker Hub. So to create a token in Docker Hub, you can go to your profile and click on account settings. Then here you can scroll down to security, then the personal access tokens. Then here you can click on generate new token. You can give a token description, then access permission that can be read, write and delete. Then click on generate. Then you can paste that particular token in password. Here you can see login is succeeded. So now I am authenticated. Now I can push the image to particular repository. I will run docker push now. Now it pushed my image to Docker Hub. Now if I go to my Docker Hub and check my repository, here you can see last pushed is 1 minute ago. And if I check that particular repository, here you can see the tags that are pushed. Version 1.0 is pushed here. Like this, you can push your images to Docker registry. Now your peer developers or colleagues can pull this image and they can use that particular image. And one more thing, Docker tag can be created while creating the image only. Earlier we tagged the existing image. Now let me tag the image while creating the image only. So while creating the image, I can add -t, then the repository colon tag name. Here I have added tag as version 1.1. If I run this now, image is created now. It should have a tag also now. Here you can see the newly created image and it created 43 seconds ago. And if I want to push this image to Docker registry, then I can run docker push now. It is pushed now. And in Docker Hub, you can see two tags now, version 1.0 and version 1.1. Now I will delete my local image. Then I will pull the image from Docker Hub. For deleting image, you can run docker RMI, the image ID or our tag we have created just now. Image is deleted now. Now I can pull the image from Docker Hub. So it downloaded the newer image now. Like this, anyone can pull this image. For pulling, authentication is not required because this is a public repository. Now anyone can create their own container from this particular image. So for creating the container, I can run docker run, then -p, then the host port and container port, then image ID. Like tagging the image, I can give a name to the container also. For that, I can use -hyphen name, then the container name. This container name can be anything. I have named it as node app. And if I run this now, so it created a container now. And if I check that in browser, I can see the application is running now.
In previous sessions, we have created a lot of Docker images and Docker containers. Let's clean up those today. If I run Docker images, you can see there are 3 images are listed here. Now I want to clean up or delete these images. But before deleting any image, we have to check whether any containers use that image. So if any containers using that particular image, we have to delete the container first. We can run docker ps to check the running containers. So you can see these containers using this particular image. So before deleting the image, we have to delete this particular container. When we directly delete the container, the answer is no. We have to stop the container first. So to stop the container, you can run docker stop, then the container ID. So let's run this command now. Container is stopped now. Now I can delete the container. If I run docker ps-a, it will give both running and stopped containers. Here you can see some 6 containers are in stopped state. Now if I want to delete any stopped containers, I have the command docker run. I will run this command now. Now this container is removed. Now if I again run docker ps-a, only 5 containers are listed because we removed 1 container. So like this we can remove the individual containers. Like this, if I have some 100 stopped containers, then I can't delete the containers one by one, right? That will take a lot of time. So one way of deleting multiple containers is giving multiple container ID for docker run command. So like this we can run. So now we deleted 2 containers, and now if I run docker ps-a, it has only 3 containers. Now if I want to delete all the containers, then I can run the command docker rm $docker ps-aq. So here we know docker ps-a gives list of containers. We are adding q also. Q means quite here. So it will give the container ID only instead of all these details. So docker ps-aq will pass all the container IDs to docker rm command. So now if I run this command, so it deleted all 3 containers now. So if I had some 100 containers, it should have deleted all the 100 containers. So now if I run docker ps-a, there are no containers now because we deleted all the containers. So this is how we delete the containers. So you have to stop the containers first if it is running, then we can run docker rm command. In some cases, I don't want to keep the stopped containers. Whenever I stop the containers, those containers should be automatically deleted. I can achieve that also using --rm flag while creating the container. So in docker run command, I can add --rm flag. And if I run this now, it created a container in detached mode because I have added a -d also here and the container is running. Now if I stop this container, it should delete the container automatically because I have added --rm flag. Let's run this now. It stopped the container now. If I run docker ps, there are no containers here. Also if I run docker ps-a, there are no containers now. That means when I run docker stop, it deleted that container also because of this rm flag. So that is about deleting the containers. Now let's see how to delete the images. For deleting the image, we have the command docker rm. Then we can pass the image ID. Like in containers, here also I can give multiple image IDs to delete multiple images. So when I run this, deleted this image. Now if I run docker images, I have only 2 images. And if I want to delete all the images, then I can run the command docker rmi. Then I can pass all the image IDs using docker images -q command. We know docker images will list all the images. We are adding -q also here so that it will list only image IDs. So docker images -q will pass the all image IDs to docker rmi command. So now it deleted all the images. Now if I run docker images command, there are no images.
Come on guys, let's learn docker volumes today. We know docker image consists of source code as well as dependencies, and image is read only and locked. So every time source code changes, you have to build a new image. Then from that new image, you are going to create a new container. So like this, you are going to create a new version of Dockerized application. Now consider an example of Dockerized web application. Consider this web application has some kind of feedback forms, and users fill those forms and the response will be stored. That response data will be stored inside the container. Now consider source code of this web application is changed. So you have to build a new image and you have to build a new container now. Now the container 1 is deleted and a new container is created. But what happens to the user data that is stored in container 1? That data also get deleted because that data stored in file system inside the container 1. Now container 2 don't have this particular user data. So now data is lost. Now this data is temporary, then it is fine. But if this data is important and it is permanent data, then data generally stored in database. That data called as persistent data. So to store permanent or persistent data, we have something called as Docker volumes in Docker. So in this case, even when deploying a new application version, when we delete the old container and spin up new container, the old data should not be lost. Now let's see how this will work in demo. Now let's create a feedback application first. For that I need source code first. My source code is ready and it is in GitHub, and I'm going to share this link in video description also. Let's clone this repository first. I will copy this HTTPS URL, then git clone and paste this HTTPS URL. The repo is cloned and the code is in Docker volume directory. My source code is here. Now let's create a Docker file, v8 Docker file. This is the node application. So first step will be pulling the node base image. We can provide the node version also here. I have provided 14 as the node version. Then change the work directory to /app. Then copying the dependency file, that is package.json, to current directory. then installing those dependencies, then copying the source code to the current directory. Here current directory is /app, then port is 80 here, and at last we are running the node application. Here we have two separate steps to copy the dependencies and copy the source code, because whenever the source code is changed, every time there is no need to install the dependencies. So this will save the image build time, and we know run will execute while creating the image and cmd will execute while creating the container. And check out my first video for more explanation of Docker file. Now let's save this file. Now Docker file is created. It is in the same directory as source code. Now let's create an image from that particular Docker file. I'm going to run docker build and I'm going to tag it as wall, and Docker file is in the same directory. That's why I'm giving it as dot here. Let's run this. Now it created a new image. Let's create a container. For creating container, I'm going to run docker run. The -p 3000 is host port and 80 is container port. Then -d is for detached mode, and I'm going to name this container as wall-app. Then I'm adding -rm flag so that when the container is stopped, it is automatically get deleted. Then the image name wall. Let's run this now. Now it created the container. Let's access this in browser. If I open this application with my IP address and 3000 port, so this is my feedback application. Here I can give a title for my feedback, and here I can describe that particular feedback. Now if I click on save, then it will create a file in feedback folder. The file name will be the title of this particular feedback, and it will have txt extension. Now let's click on save. Now if I go to feedback folder and my file name, that is super.txt, it will give my description here, that is it is good. So here user feedback is saved in a particular file. Now what happens when the new application version is deployed? It means it will delete this container and it will create a new container, right? Now let's delete this container, then we create a new container, then see same feedback file is exists or not. Let's stop this container now. When I run this stop command, it will delete the container also because of this -rm flag. Now you can see there is no containers here. Now let's create a new container. Container is created. Now let's see whether the same file is exists or not. We got an error, cannot get this particular file. That means file is not there. So when the new container is created, the data is lost. We don't have the user response now. To solve this issue, we have Docker volumes. Let's see how it works now. Let's implement Docker volumes now. There are two types of Docker volumes. One is anonymous volume and the second one is named volumes. Let's first create an anonymous volume. For that, we have to add additional instruction in our Docker file. We have to add a volume instruction here and the directory, that is /app/feedback. Now let's save the Docker file. Now let me delete my previous container and previous image. Docker stop deleted my container. Now docker rm deleted my image also. Now let me build a new image from new Docker file. Now it created an image. Now let me create a container. Now it created container also. Now if I check that file, obviously that is not existing. Now let me create a new feedback. I have created feedback with the same title now. Let me save it. Once I clicked on the save, the app is crashed now. Let's check the logs and see what happened here. We got an error like cross device link is not permitted. So once we clicked on save button, first it will save the file in temp folder, then it will move the file to feedback folder. Now once I added volume instruction, we are receiving the error while moving the file. So to solve this, we can modify the code. You can modify the server.js file. Here instead of rename, you can use copy and unlink. So here instead of rename, I used copy file. Once I copy it to final path, then I delete or unlink the temp path. Copy and delete is nothing but move. Now let me save this file. So once the source code is modified, I have to build the image again. That is the rule. Before that, let me delete my container and the image. I have deleted my container and the image. Let me build a new image with new source code now. So new image is created. Now let me create a new container. So container also is created now. This is the previous page where app is crashed. Now let me refresh this. Now I have added the feedback and let me save this now. Now if I go to that particular file path, now it is not crashing. So content is saved here now. Now let me delete this container and see whether the data is persistent. Container is deleted. Now let me create a new container. New container is also created now. Now if I refresh this page, I still get this error. Then what's the point of adding volume? Do we know whether the volume is created or not? How to check? For that, we have a command called as docker volume, and we can add a ls also here. So we have one volume here. The volume name is some random name. We don't know the location or name of this particular volume. That is why it is called it as anonymous volume. Now this is of no use because data is not persisted here. Now let's create a named volume and see whether the data is persisted or not. And before that, let's clean up the container and image. Both the container and image is deleted now. First we will remove the volume instruction from the Docker file, then save the Docker file. Now let's create a new image. Now let's create a container with the same command but with additional flag, that is -v or -volume flag. Now this is named volume. So feedback is the name, /app/feedback is the destination directory. Now let's run this command. It created a container now. Now let's create a new feedback and save it. It is saved now. And if I go to that particular file location, I get the description of the feedback. Now one more time, let's delete and create a new container. Now if I check docker volume ls, I get a named volume, that is feedback. Now one more time, let's delete and create a new container and see whether the data is persisted or not. Container is deleted now. Let's create a new container. Let's create a container with the exact same command, exact same -v flag. Now new container is created, and if I refresh this page now, data is there. If I refresh 2-3 times also, you can see data is there. That means data is persistent. Finally, we achieved our goal. With the named volume, that data is persistent now. So that is the importance of Docker volume. Hi guys, in the previous session we learned about Docker volumes. Today let's learn about bind mounts. We know that Docker volume can be used for persisting the data even after deleting the container. But we have one more problem with the containers. While developing your application, if you modify your source code, then to reflect that change in your application, you have to rebuild the image again. Then from that image, you have to recreate the container. Then only that source code changes will reflect. Then what if I want to see the source code changes in my application real time? For that use cases, we can use bind mounts. Bind mounts are your Docker volumes only, but you can attach that into path in your host machine. So if you modify the source code in that particular path, in that host machine, the changes will reflect in container in real time. So volume will provide data persistency and bind mount will provide data persistency, also real-time editing of your source code. So let's see in the demo how bind mount works. Currently there are no running containers. In previous session, we attached the named volume, that is this feedback. Now I want to attach this whole source code folder as a bind mount. For that I can use same -v flag. In case of named volume, we provided only name for the volume, that is feedback. In case of bind mount, we have to provide the absolute path of our source code folder, then colon and directory in the container. This will attach our whole source code folder into a folder in a container. Let's run this now. Now it created a container, and if you check the application in browser, it's not working. And if you run docker ps command, the container is not running. And if I check the log of that particular container using docker logs command, I can see the error here. It cannot find the express module. It is a Node.js module actually. Previously it was working fine, but what's the issue now? After adding bind mount, we got this issue. So what happened here is, when we run this command, whole source code folder data is added to /app directory, and it overwrites the data that already exists in /app directory. If I check Docker file here, we have the step to copy the package.json file. Also, we have a step to copy whole source code here. And when we run npm install, it will install all the node dependencies. Also, it will create a new directory as node modules. And when we run this command, this bind mount will override the content in /app directory. That means it will also override the node modules directory. That's why we got an error like express module is not installed earlier. So to resolve this, we can add one more volume here. If we give like this, node modules directory will be preserved. And we are not providing any name or path here. That means this is a anonymous volume. So this is one of the use case for anonymous volume also. Let me run this now. It created a new container now, and the application is working now. And I can add a feedback also now. So now let me modify the source code. Let me modify feedback.html file that is in pages directory, vi feedback.html. I added valuable here. So right now here we have provided your feedback title, and if I save this file now, it should add an additional word valuable. File is saved. If I refresh this page, you can see there is a change here. Now it is provide your valuable feedback. So this is the use case for bind mounts. Data is persisted. Also it is editable in real time. Also if I attach the bind mount, I don't want container to change my files in host machine. If source code changes are there in host machine, it should reflect in container, but vice versa should not happen. For that I have to make this volume as read only. I can add :ro here. Ro means read only. And if I make whole directory as RO, for that we have a conflict here, because in this particular application, it stores the user response in temp directory as well as in feedback directory. So temp and feedback directory should be read write, not read only. If you add arrow here, whole /app directory will be read only. So to avoid that, we should add feedback and temp directory as separate volumes. Here feedback directory is already added, and we have not added RO here. So feedback is writable folder here. And I can add one more volume /app/temp and without RO. So, and /app is RO. And whichever command is bigger and specific path, that will take precedence. Even if we add /app as RO, /app/temp is writable because bigger path wins. So with the RO flag, we can make volume as read only. Also, we can manage the volume with docker volume command. If we run docker volume ls, it will list all the volumes present in this particular host. Also, we can use docker volume rm to remove the volumes. If I run this feedback volume, will be removed. When I run docker volume ls, only 2 volumes are present now. Also, we can create volume using docker volume create volume name. If I run this now, a new volume is created now. Generally, we don't use this particular command. While creating the container, when we use -v flag, it will create the volume by default. So there is no need to run docker volume create command. But if you want to explicitly create a volume, then you can use docker volume create command. Also, you can run docker volume -help command. It will list all available commands. For example, I can run docker volume inspect command, so that it will list everything about that particular volume. Also, in terms of Docker file, one more question is, do we need this copy command to copy the source code? because bind mount already have the source code. Let's comment this instruction and rebuild the image. First, let me remove the old container and old image. Old image is removed. Let me create a new image now. It created a new image now. Let me create the container now. And the container is created now. And also app is working in browser. Also app is working fine, even without this copy instruction. So this copy instruction is not required, right? That's not true actually. We use bind mount while developing the application because we change the source code frequently. And if you want to know whether it is working or not, we use bind mount there. But when you deploy the code in production server, we don't use bind mount there. We use volume for data persistency in production also, but we don't use bind mount in production. So in that case, we should include this copy command in Docker file. So I have removed the comment now and I will save my Docker file. Come on guys, let's learn about Docker arguments and environment variables. Docker support two types of variables. One is arguments and another one is environment variables. Arguments we generally add it while building the image, and env we add it while running the container. Arguments we generally add it inside the Docker file. Also it works with most of the Docker file instructions except instruction like cmd, because we already know cmd instruction will run while creating the container, not while building the image. Env also we can add inside the Docker file. Also we can add env inside the source code. While building the image, we can add ---- build r flag to specify the arguments. Similarly, while creating the container, you can add ---- to specify the environment variables. So this is about arguments and environment variables. But why do we need this? Instead of hard coding everything in source code or Docker file, if you want to assign the values dynamically, then you can utilize arguments or environment variables. Let's see those in action. Let's see env first. I told env we can add it in application code only. Let's do that now. I am modifying server.js file now. In server.js file, you can see application port is hard coded here. Instead of hard coding port 80 here, I want to use the environment variable. In Node.js code, I can mention env as process.env, then dot and the environment variable name. That can be anything. I'm adding it as port here. Generally, we add it in capital letter. Now I'm saving this file. Also, we can mention env in Docker file. Let's see how that works. Vi Docker file. Then in Docker file, I can add instruction for environment variable. Instruction will be env, then the environment variable name that we have mentioned in our source code, that is port. Then we can add a default value here. I will add 80 only. Then in this expose instruction, instead of 80, I can add port. I can add expose port. But syntax for variables is different. I have to add $ also. Let me save this Docker file now. Let's create new image from this particular Docker file. And I'm going to add a new tag for this image, that is env. So let's run this command now. We got a warning here. You can see the format we should be used here, env key equal to value. So let me delete this image and modify the Docker file again. Image is deleted using docker rmi command. Let me modify the Docker file again. So here instead of space, I have to add equal to sign. Let me save this Docker file. Let me create the image again with env tag. Image is created now. Let's create a container now. I can use the same command that I used in previous session, but for the image I will add a env tag. Also here you can see the internal port is 80 only, because in Docker file I have mentioned default port as 80 only. If I want to override that while creating the container, I can mention the --env flag. This is for environment variables. Then I can add an environment variable name, that is port. Then I can mention a different port here. So I have added 8080 port. I have to mention the same port here also. That is 8080 instead of 80. Now the host port is 3000 and the application port is changed to 8080. That's it. Let's run this command now. So container is created now, and in browser also application is working fine. And if you have multiple environment variables, then you can add multiple --env here, similar to multiple -v added in previous session. Or instead of --env, you can add -e only. Both work. And one more way is creating the .env file. So vi.env. Here you can specify the multiple environment variables. You can add port is equal to 88. You can specify the multiple environment variables in this particular file. And the file name can be anything. Generally, we name it as .env file. Then while creating the container, you can add -env file instead of only -env. Then you can specify the path of that particular env file. That file name is .env and file is in the same directory. You can mention that as /the file name. So that's it about env file. While building the application, we will have the different environments, and variables values in these environments can be different. For the same environment variable, in dev we will assign a different value, and in prod we will add another value. For dynamically assign the values, you can create different .env file for different environments. So that's it about env. Let's see the arguments now. We know arguments we can mention in a Docker file. We can't mention that in source code. So let's modify the Docker file now. Vi Docker file. Here in env, we have added default port as 80. Now I want to modify this default port dynamically while creating the image, not while creating the container. For that, I can use argument. To define the arguments, you can use the arg instruction, then the argument name. Here also I can add a default value for this. Now in env, instead of hard coding this, I can add it as $default port. That is the argument I defined here. Now I can save this particular Docker file. Now while building the image, I can modify that particular argument also. And I will tag it as arg, then ---- build r, then the argument name, then equal to. Now here you can add a dynamic value. Now I have added 9000 here. So let me run this now. Image is created now. Let me delete previous container, then create a new container from this new image. I have stopped and deleted the old container. Let me create a new container now. I'm going to use new image now. I have changed the tag of this particular image, and the application port should be 9000 now. because default port is 9000. Let me run this now. So container is created. For some reason, application is not working in the browser. While building the image, I added as default R instead of default port. So this is the issue. So before modifying that, let me clean up the container and the image. So stop the container, remove the container, then remove the image. Now I will correct this default underscore port. Let me run this now. It created the image now. Now let's create the container with the same command. Container is created now. Now the app is loading in the browser. So that's it about arguments. I quickly explain one more topic in Docker. That is docker ignore file. Like in Git, there we have .git ignore file. Here we have .docker ignore file. You can create this file in same directory as the source code. And if you don't want to copy any file in your image, then you can add those file or folder in this particular file. For example, if you run npm install in your host machine, then it will create a directory called as node modules in your host machine only. And if you don't want to copy those files inside Docker image, then you can add those in docker ignore file. Like this you can add. So that is the use case of docker ignore file. Come on guys, today we are going to learn some very interesting topic, that is Docker networking. So why do we need Docker networks? Consider you have created two containers in a host. One is used to host your application and another one is used to host your DB. Or you can call it as front-end and back-end containers. So obviously application should talk to DB, right? For that we need a Docker network here. There are multiple types of Docker networks. Default network is bridge network. So whenever you create a container inside a host, by default it will be part of bridge network. So here your host or VM will have its own IP address and container will have its own IP address. And generally CID range will be different. And the communication between the container and host will happen via bridge network. And if you create one more container called as C2, it will have different IP address, but it will have the same CID range as previous container. And it will also created in a bridge network only. And the communication between these two containers will happen via bridge network only. So bridge is the default network. And the second type is host network, and generally we don't use this network much. So in host network, the containers also have same CID range as the host. So if the host have 192.42.0.4 IP address, then the container will have 192.14.0.5. Both will have same CID range. So if I create one more container in a host network, it might have 0.6 address. This is not an efficient way of handling the network. That's why this is not used much. And the third type is overlay network. This is the popular network type, and this is mostly used in Kubernetes, Docker, Swarm. These kind of architecture we can use overlay network. There we will have multiple hosts or multiple nodes. And if you want a common network for both, you can have a overlay network there. So these are the three types of networkings. Now consider I have two containers, C1 and C2. And by default, both the containers will be in bridge network and they can communicate with each other. What if I don't want this? What if C1 should not talk to C2? How can I achieve that? For that, I can create custom bridge networks and I can create different containers in different custom bridge network so that they will not communicate with each other. So enough of theories. Let's go to demo now. Without wasting any time, let's create a container now. So to create a container, I can run docker run and I will use 80 port only, and I'm going to create a Nginx application. And let's see how in which network it will create. So then -d, then the image name, that is Nginx. It will take a couple of seconds to create that. So it created a container now. Now let's check the network of this particular container. For that I can run docker inspect and the container ID. So once I run this, it will show the network details here. You can see the networks and the network type is bridge, and it will have the gateway and IP addresses. Here IP address is IP of the container, that is 172.17.0.2 is the container IP address. Here gateway is nothing but the containers route to the outside network, and the first type will be the gateway IP address. If I create one more container, that will have the IP address 172.17.0.3, and this bridge network will have its own subnet range. If I run docker network inspect, then the network name, that is bridge, it will give the details of that particular network bridge network. Here you can see the subnet range. So by default the range will be 172.17.0.0/16, and the gateway containers all will have the IP range within this subnet. Also you can see the containers list in this particular bridge network. Now let's create two containers within the same network, then see how these both containers will talk to each other. I want to install some of the networking tools inside this particular containers. For that, I am going to customize this particular Nginx image. I have created a Docker file here. This is to install all the networking tools. I will give this Docker file in the description also. Let's create an image from this particular Docker file. I can just run docker build and the Docker file path, that is current directory. If I run docker images, this is the new image created. Let's create two containers from this particular image. Let's create first container using docker run Then I will name this container as hyphen name, and I will name it as C1. Then hyphen D for detached mode. Then the image ID, the custom image we have created just now. Then also I want to give the network admin privileges while creating the container. This is because later I am going to change the IP route and other things. For that, the network admin privilege is required. That's why I'm going to add another flag now. That's it. Let's run this command now. So container 1 is created, C1. Similarly, let me create C2 also. So C2 also created now. Let me run docker ps now. So both the containers are created, C1 and C2. Let me check the network details for both the containers. For that, I can run docker inspect C1. So I will get the network details here. I can see the IP address is 17.0.2 and the gateway is 0.1. And our bridge network is created. So by default, our bridge network will create and the container will be created in that particular bridge network. Similarly, if I check for C2, that is also same here. The IP address of C2 is 0.3 and the gateway is same and the network is same. Then that is bridge network. So by default, containers will be created in bridge network only. Now let me log into first container. For that, I can run docker exec -it, then C1, then the bash. So I'm logged into the container now. Here also I can check the IP of this particular container using hostname -i. So this is the container IP. I can curl this IP using curl http, then the IP address, that is 0.2. And I will get this response, that is welcome to Nginx. And in both the containers, I will get this response only because the content is Nginx content only in both of the containers. To differentiate both the containers, I want to change this content. For that, I can modify one of the file, that is index.html file basically. So vi index.html file, and I'm going to modify the content here. Instead of welcome to Nginx, I can modify it to welcome to C1. I have modified the content so welcome to C1 in both the places here. And let me save this file. Let me do the curl again. So here I can see the content is welcome to C1. Let me do the same change in C2 also now. For that, I'm going to exit from this container and log into the C2 container. Save. And then docker exec to C2. I can check the IP of this C2 was here using hostname -name, that is 0.3. Let me modify the index.html file here also. Here also I am going to change to welcome to C2. So I have modified to welcome to C2 here, and let me save this file. Now if I do the curl to C2, the curl http 172.17.0.3. So I will get the welcome to C2 message now. By default, there should be internet connectivity, so I can ping to google.com also from this particular container. If I ping google.com, it will work. So this is the IP address, that is start with 142. Also, let me try to ping to my first container, that is 172.17.0.2. Now I am in C2 container. Let me ping to C1. I will get that response also. Here you can see I will get a response from 0.2. That is, I will get the response from C1 also from C2 container, because both of these containers are in the same network. That's why I am able to ping. If I check for trace route for my C1, that is 172.17.0.2, I'll get only one entry because it will directly connect to my C1. If I do the same trace route for google.com, the first entry will be my gateway address. That means whenever container is trying to reach outside world, it will first connect to my gateway. That is 0.1 is my gateway. So gateway will provide the route to the outside world for the containers. If I try to ping C1, it will not work. I will get the error like name or service not known. Let's solve this now. For this, I am going to create a custom bridge network. Let me create that. First, I will exit from this container. Then I have the command docker network create. Then the network name, I will name it as mynet. Then I can add a subnet for this particular network. That is subnet -subnet. I can give any range here. I will provide 10.30.0.0/24. /24 means 32 minus 24. That is 2 to the power 8. Means 256 available address. That is enough for me now. So let's create. So our network is created now. Let me connect both C1 and C2 to this custom network. For that, I can run docker network connect the network name, that is mynet, then the container name C1. So there is an error. So network spelling is wrong. So network. So C1 is connected. Similarly C2. So both the C1 and C2 containers are connected to my custom network now. Let's inspect one of the containers. So docker inspect C1. Now I will get two networks here. One is bridge network, that is by default. Here my IP is 0.2, 17.0.2. In mynet, my IP is 10.30.0.2. I have the C1 is available in both the networks now. Similarly, if I check for C2, that is also similar. I will get two IPs, 10.30.0.3 here in mynet, and in bridge, that is 17.0.3. So now I am both the containers connect to both the networks. But I don't want that. I'm going to disconnect from my default bridge network. For that, I can run docker network opposite of connect, that is disconnect. Always network name first, that is mynet, not mynet, bridge actually. So bridge, then the container C1. So that is disconnected. C2 also disconnected. If I do one of inspect now, so I can see only mynet now, only one network, that is mynet. So that is done now. Now let me log into one of the container using docker exec one ID and C1 dash. Now if I try to ping one of the container, that is C2, I'm able to ping. So custom network is working. So now I want to connect C2 to another custom network. Let me create another network and let me add C2 to that network. We'll first exit from this container, prepare the string, then we'll create one more network, that is docker network create, and the name I will give as mynet2. Then we can add a different range here. In the import title .1.0 now and 24. So it takes one more network. Now I will disconnect C2 from mynet, then I will connect to mynet2. So disconnect it from mynet, then I will connect to mynet2. So now if I do the inspect on C2, now you can see the IP is changed. It is 10.30.1.2 and there is no other network, only mynet2 is. Now let me accept into C. But here then now let me do accept into C2. Then if I try to ping my C1, I can So the send of that is 0.2. That is not working because both of these containers are in different custom networks now. That's why it's not working. To solve this, I can take my own custom gateway. Let me create a gateway now. For that, I will exit from C2. Then I will create using docker run and name it as -name. I'll name it as my gateway, my GW, and -d. I need a image ID. I have copied my image ID and pasted that. Also, I want to create this GW or my gateway in mynet. So -network, -network, then mynet. So let's run this now. So it created my GW container now. Let me connect this gateway to my mynet 2 also. For that, docker network connect mynet 2 to my GW. So my gateway is connected to both network 1 and network 2 now. If I do a docker inspect on my GW, I can get mynet 2 here and the IP address will be 1.3 here. And if I check on mynet, IP address will be 0.3 here. So my GW is connected to both the networks. Now let's log into my gateway. So docker exec -it my GW and bash. So if I do ping C1 from here, it is working. And similarly, if I do ping C2 also, that is working. So here from C1, C2 is not reachable and vice versa also true. That is because both are in different network, but gateway is in both the network. That's why I'm able to ping both C1 and C2 from gateway. That's good, right? Now let me log into one of my containers C1 or C2. First I will exit from my gateway, then docker exec it, and I will log into C1. I will clear my screen, and if I try to ping my C2 IP, that is 10.30.1.2, that is not working still because both are in different network. To resolve this, I am going to add a path. Means I am going to add a IP route now. For this, I need network admin privileges. That's why I added network admin privileges while creating both the containers. Let's add IP route now. For that, I have the command IP route add, and then the subnet range of my C2, that is 10.30.1.0/24 via my network, my gateway basically. So 10.30.0.3. The meaning of this is any traffic to this particular subnet will go through via this particular gateway. Now if I try to ping C2, still it is not working. If I do a trace route to C2, first it will go to my gateway now. That is because I have added a route now. Still for ping it is not working because I am not able to get the response from C2, because in C2 also I have to add a IP route now. Let's do that now. Let's exit from C1 and log into C2. Here I have to add my IP route. I will clear my screen. Then the command is IP route add the subnet range of my C1, that is 0.0/24 via my gateway, that is 10.30. Here 1.3. So I added the gateway now. Now I will try to ping to C1 now. For that I can run ping 10.30.0.2. So this is working now. Now I am getting the response because IP route is added in both the containers. Let's check from C1 also. Let's exit here, and let's log into C1. And if I do a ping to C2 here, trace route is working, and ping also should work. Ping is also working. So that's it. I created two separate containers in separate network, and now I am able to connect from a different network also from my gateway. Come on guys, let's learn Docker Compose today. So why do we need Docker Compose? In short, Docker Compose is used to manage multi-container applications. In real-time, applications will have multiple services. The services can be login service, payment service, database service, cache service, or proxy services. These are some of the examples for different services. Here, each of these services will have its own containers. For example, my application has 10 different services. Then I have 10 different containers. So each of these will have its own Docker images. Then how do we manage these? Should we create the Docker image for login service using Docker build, then create the container using Docker run? After that, Docker build for payment service, then Docker run for the same. Should we do this for all the 10 different services? We can do that, but that is not efficient, right? That doesn't make sense. Also, there can be interdependencies between the services. For example, before starting the payment service, DB service should be up. How do we ensure these kind of dependencies? So to manage these kind of applications, we have Docker Compose. In Docker Compose, we include all of these services in a file called as dockercompose.yaml file. And we can create all of these services using one command, that is docker compose up. And we can delete all of these services also using just one command, that is docker compose down. Let's see this in action now. For demo, I'm going to use one of the GitHub repository, that is awesome compose, that is officially maintained by Docker. In this repository, I can find many multi-service applications. I'm going to use one of the project for the demo now. Here we have Nginx Node.js Redis is for cache, or Nginx Golang. I'm going to use Nginx Golang Postgres today. So we have Nginx, then for proxy, then Golang for backend, then Postgres for DB. You can find the project structure here. We have backend, DB, then proxy. Let me clone this repository into my server now. For that, I can copy the URL, then git clone, then paste the URL. This is the public repository, so credential is not required. So it will copy the code to my server now. So here you can find awesome compose, that is the repository name. And if I go inside that particular repository, I will find multiple projects here. So I'm going to use Nginx Golang Postgres. So I will go to cd Nginx Golang Postgres. Here I have multiple files and folders. So I am interested in this particular file, that is compose.yaml. That is the file which is used to create multiple services. If I check out compose.yaml file, cat compose.yaml file, I have different multiple lines here. Let's go through each of these lines. First, we define the services. Here we have three services basically. One is backend service, then is DB, then is proxy. So three main services we are using in this particular application. Here DB and proxy will have its own official images. For example, proxy will have Nginx image and DB will have Postgres image. But for backend, we are going to create the image. For creating the image, we need a Docker build. For that, I am going to add build instruction here. For Docker build, what we need a Docker file. For that, I am going to add context here. In context, I'm going to mention the directory which consists of this particular Docker file, that is backend is the directory name. If I go inside backend directory, cd backend, I'll have Docker file. So this is the Docker file which we need to build. If I cat Docker file, these are the instructions. So Docker file can consist of multiple builds. So here build is named as builder. So I'm going to use this builder build. Let's go back to compose YAML now. So here context is backend, there is the backend directory, and the target is builder. That means builder is the name of the builder. Then it uses the secrets DB password. So each backend services needs a secret, that is DB password it needs. So secrets also we mentioned in this particular YAML file only. Here you can find at the last you can see the db password secret, and the db password secret is in db/password.txt file. So inside db I will have the password.txt file, and here we have the secrets. Though these secrets we need to add this in backend. So it has db password secrets. Then this backend services depends on another service, that is db service, and the condition is service healthy. This means backend service will start only after the db service is healthy. Until db service is healthy, backend service will not start. Then db service will have its own instructions, like it will use the official Postgres image. Then restart always means whenever the this container stops, it will always restart. Then user is db user is Postgres. Then the secret is in db password only. That means these secrets only. That secrets in password.txt file. Then volumes is for persisting the data that we attach to this particular directory. Then the environment, Postgres DB and Postgres password. Then obviously Postgres will use a 5432 port, so expose that particular port. Then for health check, you are going to run this command, that is pg is ready. Then the interval timeout and retries we are going to add. So when this health check passes only, then only backend service will start. So that is about db service. Then proxy service will use nginx image. So here you can see the source is my host directory, host file, that is nginx.config file, and target is in my container. And the read only means I can't change the file inside the container. Then ports, nginx port I am going to use 80 port, and nginx services depends on backend service. That means proxy service only starts after backend service. Then I have defined the volumes and secrets. So this is the structure of Docker Compose YAML file. So we will have different services, and each services have different steps. Now I want to create this application. For that, in Compose I am going to run docker compose. Only one command is enough, that is docker compose up, and I'm going to add -d for detached mode. Then if I run this, it will start creating the services. So all the services are created now. Here you can see the db service is created first, because backend services depends on the db services health check. So here you can see db service is healthy, then only backend service will start. So now backend is started, then proxy started, because proxy services depend on backend service. All the services are started now. To verify whether it is running or not, I can just run curl command, curl localhost, then the port is 80 here. So if I run this, I will get this particular response. So in the application, we have blog post 0, blog post 1, blog post 2, these kind of details. So here I check the code in backend and in main.go. Here you can see in loop we have added blog post %d. That means it will print those blog post 1, 2, 3, 4 like that. Also I can check this particular application in a browser also using IP, then :80 port. So here you can see the application is up and running. So I will get the same details when I do the curl. So that's it. This is how we can create a application using Docker Compose. Then if I check Docker PS here, that is, it will list the running containers. Here you can see 3 containers are running. One is Nginx, then Postgres, and the another one is we created the backend container. So here there is no need to run docker run command separately for different containers. So I can just run docker compose up. And if I want to delete all of these services at once, I can just run docker compose down. So it's going to remove all of these services. Now if I run docker ps, all the containers are deleted. And if I go to my browser and if I refresh this, I should get the site can't be reached message now, because all the containers are deleted. So you can see this response now, because all the services are deleted.